here are your answers. We did, I think, 1 through 6 in class last time, and we talked about the justification being the alternate interior angle converse, et cetera, et cetera. I'd like to look at questions 7 and 8 a little bit more particularly, or a little bit more closely, because we are going to start something called proofs today. And 7 is what we call kind of like a flow proof, because it kind of has these little bubbles, and it looks almost like a flow chart, I think. And so if you look, we're given and we're asked to prove something. And that is going to be something that we're going to be looking at a lot today. You're going to be given something and asked to prove. So look at what your given statement is and what you're asked to prove. So we are given that 1 and 2 are supplementary. Okay. Problem with questions 1 and 2, angles 1 and 2 is, do they have a special angle pair name, angles 1 and 2? Is there one common transversal for angles 1 and 2? No. So I can't use the alternate interior angle theorem or corresponding angle theorem or anything like that. We are told that x is parallel to y. Okay, that's some good information. So let's look at the proof. Okay, so we are given this, and what we had to fill in what was in red. So right here is what you were asked to fill in, and I don't think a lot of us knew all of that needed to be filled in. So if you would, please add this information to your flow proof, what I've highlighted here. I'll go ahead and turn the lights down a little bit so you can see probably a little bit better on the board. There we go. Brian, can you still see okay? Okay, good. So if x is parallel to y, so I'm going to go ahead and just make those our parallel lines in our picture. And we know that by the same side interior angles are supplementary. So which angles are the same side interiors? In that particular case, it's 2 and 3. So we know that 2 and 3 are supplementary. Okay. Now, what are we given? 1 and 2 are supplementary. We're given that information right here. 1 and 2 are supplementary. So that's why we can write here that that's the reason. So anything that's inside a bubble in a flow proof is going to be a statement. Anything written out underneath it is going to be the justification, the reason, okay? And so we're just given that information. All right. So why would angles 1 and 3 be congruent? Well, if 1 and 3 are congruent, because we know that angles supplementary to the same angle are congruent. 2 and 3 are supplementary. We agree with that. 1 and 2 are supplementary. We're given that. So if 2 and 3 are supplementary and 1 and 2 are supplementary, can't we say that 1 and 3 have to be congruent? Sometimes we call that substitution. We're going to look at that a little bit today. This is not a reason that we've ever used in class before, so I understand that. So we'll look at a different way to look at this proof in a little bit. This one's kind of like a little, I get that maybe we didn't quite understand. If I happen to know that 1 and 3 are congruent, just looking at angles 1 and 3 right now, okay? So we're looking, oops, writing all over the place here. Just angles 1 and 3. What kind of angles are 1 and 3? Well, we're saying they're congruent, but what kind of angles are the name? Alternate exteriors. Good. So if 1 and 3 are congruent, then I know that, don't I know that Q and R have to be parallel? Because if I have that 1 is congruent to 3, don't I know that because of the alternate exterior angle theorem, that the lines must be parallel? Would you agree with that? Lines are parallel. Yes, no? Now, I personally don't like these flow proofs. I think they're jumbled. They don't really, I'm a much more linear thinker. And the proofs that we're going to be doing today are going to be much more in tune with, like, statements and reasons. 2 columns, very methodical, very linear thinking. I think you'll like them a little bit better as well. Let's go ahead and double check our answers with 9 through 14. So I'm not sure, there it goes. Go ahead and check here. So we have the value of x and then the angle. So in number 9, it was x was 18 and the angle measure was 42. And so just double check your answers with those there. And we can go over any ones that you weren't sure about how to do or any ones that you got incorrect. So let me know which ones you'd like to look at. When you have parallel lines, when you write the equation is the two angles equal each other, or what's the other option? They add to be 180. So those are really your two options. They're either supplementary or they're congruent. Okay? Let's go ahead and look at the last little few here. We're looking at the reason why these things are parallel. So I'll pause while you guys check your answers. Let's look at the possible answers that you guys came up with G. So it says write an expression and choose one for one of the angles in terms of x that will prove that G and H are parallel. So pick one of the angles. So for example, if I wanted to look at this, well, let me use a highlighter here. If I wanted to use this particular angle, like right here, what kind of angles are those two corresponding? So I know that x would have to equal what? 136, and I could write that if I wanted to. Okay? Or I could say, if I wanted to make this 2x, we could solve for x and say 2x equals 136. And what would x have to be in that case? What's 136 divided by 2? So we have 68, right? So there's so many different ways you could do this. And I just picked that one angle. I could pick a variety of other angles as well. It doesn't matter. But I'd like to look at problem number 8, because problem number 8 is the one that I graded for extra credit. So if we could kind of look at this one, and I want certain people to read their answers. So we know that the measure of angle 1 is 45 degrees, and we knew that the measure of angle 2 was 45 degrees. What kind of angles are 1 and 2? Shreya? Alternate interiors. Very good. And if they're congruent, are the two lines parallel? Yes. So I know right away that these two lines are parallel. Do you agree with that? Okay. Now we're worried about angle 3. Okay? And angle 3 is part of the other line. And we have that it measures 145 degrees. How does that change some things? Okay. I really like Julia's response. Would you read your answer for us? I thought that was really thorough.
The first two lines are alternate interiors, so they are parallel. The angle vertical to 2 is equal angle 2, so only 145, not 180, so they're not parallel to the other two lines.
Okay. So what she basically said is we have alternate interior angles. So yes, these two lines are parallel. However, she used words like vertical. I loved it. 45 degrees right here. And I know that these two, angle 3 and that vertical pair, have to be supplementary. But 45 and 145 do not add up to 180. They add up to 190. So they cannot be, this third line is not parallel. So the one that I'm highlighting here in blue is not going to be parallel to the other two. Okay? So you guys need to change your answers. I saw so many yeses. So please cross that out. It is not true. Okay? Only the two lines are parallel, not that third one. All right. So what I'd like us to do is, in your packet, do me a favor. Okay? We're going to start by looking at, actually, we're going to do some algebra ones first. Okay? Go ahead and take your notes out and go ahead and call this today Proofs with Parallel Lines. Today is October the, goodness gracious, what is it, 17th? So October 17th. This is the last new thing that we're going to do with parallel lines. Your test will be next Tuesday, okay, on parallel lines. So we're just going to, your homework is going to be to review for your test. We're going to look at the proofs. Now, proofs for our part, is going to be extra credit on your test, okay? You will not have, next Tuesday you have a test on all parallel lines, everything we've done so far. And at the end of class today, I will tell you what the sections are going to be on your test. One of the sections are constructions. Remember how we did 3 constructions last time? Parallel lines, perpendicular through a point on, perpendicular through a point not on. Okay? You will have to do those 3 constructions on your test as well. So you need to practice those over the weekend. For extra credit, you will have a proof. Okay? So we're going to spend some time today looking at proofs, kind of introducing the idea of what a proof is. And I want to start with a kind of a proof that you would already know how to do. And do me a favor, keep your reason sheet that you started kind of out to the side. I love how Emma has her reason sheet right off to the side of where you are. You want to kind of keep that out all day, okay? Because we're going to use only reasons that are listed on your reason sheet, okay? Only these reasons are allowed to go into what we're doing, okay? So how do I set up a proof? So go ahead and write this down on your problem. This is your first example, okay? We're going to be always given something, and we're going to be asked to prove something. You'll be every single time, that's kind of like the problem, okay? What are you given? What are you asked to prove? So I want you to write these things down for me. Doesn't want to erase. Interesting. Anytime I'm asking you to do a proof, what I'd like for you to do is to create 2 columns. Okay? Not like the flow proof with the bubbles that you had for homework, which can be a little confusing at times. Here we have a statement column, and you're going to have a reason column. And you're always going to set up the proofs the same way every time. Okay? And this one only has a few steps, so you don't have to make it super large. A little 2 columns is fine. And we're going to set up our proof the same way every time. You're going to number your statements and reasons. Whatever statement you put here, you're going to number the reason, and that you're going to justify what you said. Kind of like the justifications that we've been doing all along. Okay? And then you can, and we'll number them. We know that there's more than one step. These 3 things that I'm highlighting here, you may fill in for every single proof, no matter what, without knowing a darn thing. Okay? They're the same every time. Okay? So even if you don't know anything about proofs, you can at least get these 3 things right. The first statement is always, always, always what's given to you. Okay? So in this case, it's 3x minus 4 is equal to 5. Sometimes it'll be 2 lines are parallel. Sometimes you'll be given that angle 1 is congruent to angle 2. You'll be given a variety of things. Whatever follows that word given always goes there. If you look at your reason sheet, what's the number 1 reason you see on your reason sheet that you copy down? Given. So what do you think the reason's going to be for number 1? Given. It was given to us. Again, you may not write anything down for a reason that's not on this reason sheet. Okay? So I will let you use this for all the proofs that we do. Okay? We're going to get used to, that's why I'm going to put it in a page protector. I think it'd be easier so you don't ruin it. Okay? I'll bring those back next time. I'm sorry. It's not the last reason that's the same. It's the last statement that's the same. So this guy right here. So my apologies. Okay, all 3 of those will always be the same. Now, I don't know what statement number it is. All I know is that it's going to be the last statement. The very last thing that I'm going to say is what I'm asked to prove. X minus 3. Okay, so it might be step 2, 3, 4. I'm not sure what step number it is. I just know it's the last one. Now, on your reason sheet, do you see the word prove? No, it's not listed there. So it should never go as a reason, ever. Okay? Those 3 things are the only 3 things that will always be the same. Okay? And you can fill those in no matter what. So let's continue to go on. Let's fill in the rest. So if I know from my algebra days that I wanted to solve this algebra equation, what would I do first to solve the equation? I would do what? I'd add 4. Look at your reason sheet. Is there something about addition or subtraction on your reason sheet? So that's the reason you're going to put. You're going to put the addition property of equality. And I'm fine if you just write prop of equal. That's fine. Okay? And if I were to add 4 to both sides, what would the equation now look like? 3x equals 9. Okay? So you don't have to show me plus 4. You just simply, you justified it with your reason that you added. Okay. Thinking back to algebra, what would the next step be to solve for x? Is division or multiplication one of the things on your reason sheet? Okay, it needs to be. So if you would, addition, subtraction, if you would, we don't use division that much in geometry, but if you would, go ahead and just say addition, subtraction, and then just go ahead and say multiplication, division. Okay, so it should be addition, subtraction, multiplication, division. They're all of those basic properties, algebraic properties that we can use. Okay, so it should be there as well. So the reason, and if I were to go ahead and divide, so if I use the division property of equality, what would I get if I divided both sides by 3? X equals 3. Wouldn't I get my proof statement? And I'd be finished, wouldn't I? Okay. So this happened to be a quick 3-step proof. No big thing. I'm going to give you guys an algebra 1 to try before we start looking at the geometry ones. Okay, because I think the algebra ones you can kind of think about and understand, and they're good for teaching how to structure the proofs, but we got to get to the geometry ones too. So let's try another one. Okay, I'm going to be giving you something, and I'm going to ask you to prove something, and I want you to try it on your own. Okay? So go ahead and try this proof. So I love the 2 columns. One thing I do want you to make sure that you are writing up here is you tell me which side is the statements. So I want you to label them statements and reasons. I think sometimes I get lazy and just write SR. Okay. But we have our first statement is always our given statement. Great job. We went ahead and used the addition property of equality. We added 4, and then the division, and we divided. Like pretty basic, wouldn't you say? Don't forget that these 3 statements are always the same, right? Or they're not the same. That can be given to us no matter what. So if you would, I'd like us to add a few more reasons to our reason sheet. Okay, and these are specific to parallel lines. Okay, so if you would, specific to parallel lines. So I went ahead and wrote this statement, and it goes with 10 through 13. Okay, so you can kind of write these together. They all go with that statement. So rather than writing that statement 5 times, I wrote it once. Does that make sense? Okay, so you're going to add this to your reason sheet. If two lines are cut by a transversal, then these things happen. Okay, so you can write it once, and you can just kind of group these next together. So add these to your reason sheet. These are going to be things that you can specifically say as a reason. And also, don't we know this as the corresponding angle converse and the alternate exterior angle converse? I mean, didn't we write those on our flip charts and in our graphic organizer too? So we've already seen these. It's just a matter of putting them on our reason sheet. Let's try these, guys, okay? So you have your reason sheet out handy. Do me a favor and open up your packet, and I kind of took a screenshot with a camera for the proofs that you should see. And these are kind of multiple choice proofs. We're going to start with some easy ones, but you should see it in your packet. Just go ahead and open it to the next page, and it says proving lines parallel. And I believe this is the one that you guys should see here, correct? Double check me. So I think that's the first one, right? Okay. So these are multiple choice. I've gone ahead and written the statements in the correct order, so you don't even have to do that. Notice that what was given was here, okay, and the last statement is what you're asked to prove, okay? So we have it matched up with what we think. It's what's different. I'm going to correspond the right colors here. What's different is that these reasons over here are mixed up. So these are all the reasons. We just need to put them in the correct order, okay? The statements are in the correct order. These are the right ones. We just have to match up the correct reason. So looking at the first particular statement, angle 1 is congruent to angle 2. Why is that a statement? What is always our first reason? Given. Good. So I'm going to go ahead and write number 3 over here because that's our given statement. Once I've used it, I'm just going to cross it out, okay, just so I know that I've used it. Now, why would angles 2 and 3 be congruent? So look at your picture and decide what kind of angles 2 and 3 are. And what do you think the reason for there would be? The vertical angle theorem. And I think you guys wrote it on your answer, your reason sheet as vertical angles are congruent. And I think I put in parentheses vertical angle theorem, didn't I? Hopefully that's what I was supposed to do. It was number 8 on your reason sheet, right? Okay, so it's there. So vertical angles theorem, I agree. So that's statement 4. The vertical angles are congruent. So here's something that we haven't talked about, but you did it back in algebra or pre-algebra. These properties, the reflexive property, the transitive property, and the substitution property. So this is the transitive property. If you guys, it's kind of like a flashback. Oh yeah, do you remember? If 1 is congruent to 2 and 2 is congruent to 3, can't I go from 1 to 3? They're congruent to each other. That is called the transitive property. You should have learned that back in algebra 1 or pre-algebra. Did you guys learn that? Some did, some did not. Help me out. No? If you did not learn it, that is what the transitive property is called. You are going to have 2 statements prior, just like this. Okay, 1 and 2, and then notice that it starts here. So 2, 1 to 2, 2 to 3. 1 to 2, 2 to 3. And then the third statement is simply going to be that this is, it's kind of like the 2's cancel out, so to speak. 1 goes to 3. Okay? That's called the transitive property. So that's what here is the transitive property. Okay? So again, if I have 1 equals 2, 2 equals 3, the transitive property, the last statement would be 1 equals 3. Okay? These things, that would be the transitive property. 2's are the same. And then the last statement, I have to say this. Now, if your prove statement says, I'm trying to prove lines parallel, your reason had better end with, then the lines are parallel. Right? Then the lines are parallel. How many choices do you have on your reason sheet that end with the words, then the lines are parallel? A lot more than one. I have 10 through 15, don't you? All of those end in, then the lines are parallel. So we have to make a decision, and this is multiple choice, so we know that the answer is 2. Are angles 1 and 3 corresponding angles? Yeah. So if corresponding angles are congruent, you just told me they are, then the lines are parallel. Okay? So we have a few of these multiple choice proofs. Again, I just want you to look at the statements and as they are. They're in order. You need to match the correct reason with them. So I want you to try them first on your own. You can talk to the people at your table, see if you get the same thing. You should know where the given statement goes. It's what's given to you. And then we'll look at those next few in a couple minutes, okay? But just rearrange the reasons in the correct order.